Good morning students. I am Asha Pawar working as an assistant professor at SNJP's Let's Serve KBJ College of Engineering, Sandwad, Nasik. Student, in last session we learned specialty polymer, that is polycarbonate, and we start the biodegradable polymer, that is the definition of biodegradable polymer and the factor responsible for the biodegradation, that is microorganisms, environment and nature of polymer. So what is biodegradation? It is the process of converting polymer material into harmless simple gases by the action of enzymes of microorganism and water. So there are three factors that responsible for the biodegradation, that is microorganisms, environment and nature of polymer. So one of the polymer included in your syllabus as a biodegradable polymer, that is polyhydroxybutyrate-hydroxyvalarate. It is also known as PHBV, or it is commonly known as a biopole. So what is the structure of this PHBV? This is a copolymer of hydroxybutyrate and hydroxyvalarate, that is four-membered alcohol and five-membered alcohol, and it is produced by a bacteria, that is Eutropus, when grown in the presence of glucose, either propionic acid or valeric acid. Means it is a copolymer. It containing two different monomers or polymers, that is hydroxybutyrate and hydroxyvalarate, in presence of Eutropus bacteria. And biopole is a trade name of PHBV, and this is the structure. See, this is the butyric, that is hydroxybutyrate part, and this is 1 2 3 4 5, it is a hydroxyvalarate part, and such a repeated number of units present in the PHBV, that is a biopole. Simple linkage of carbon oxygen or carbon carbon or carbon hydrogen. So it is easily degradable in presence of the bacteria. Then properties of PHBV: as hydroxyvalarate content increase in the range of 0.2%, polymer flexibility and toughness increases. Hydroxyvalarate means this part, that is a five-membered acid part, 1 2 3 4 and 5. This part if increase as a 0.2%, then the characteristic or the properties of polymer, that is flexibility, toughness, increases. Melting point reaches minimum at about 30% mole hydroxyvalarate, that is it is a melting point is less, and if 30% mole hydroxyvalarate is there, then melting point is minimum, that is low. The resistance of PHBV to oil is a very good, means if oil is there in contact with the PHBV, the resistance of that oil is very good. Polymer is moisture resistance and impermeable, that is a transparent. Polymer is moisture resistance and transparent. It is a susceptible to hydrolysis above pH 9 and below pH 3, means it is more stable in the range of pH, that is 3 to 9. It can be dissolved in a number of chlorinated solvent like chloroform and methylene chloride, that is in the presence of organic solvent it get dissolved. Then applications: it is most widely or very important polymer in the medical field. PHBV are used for a controlled drug delivery. The PHBV copolymer are suitable as a matrices for controlled release of drug due to their favorable biocompatibility and biodegradation properties. Means this biopole or PHBV is used for the controlled release of drug because of its biodegradation properties and biocompatibility properties. PHBV are currently used for the internal sutures. because it is a non-toxic, biodegradable, so it does not have to be removed after recovery. Disposable personal hygiene. PHBV can be used as a sole structural material or as a part of a degradable composite that used in the medical field. Packaging. PHBV can be used for the film, blow molded bottles and as a coating of paper. That is, in packaging industry it mostly used because it is very easy to prepare a thin film from the PHBV material. So flexible or blow molded bottles can be used prepared by using the PHBV. So the important point in the PHBV, that is application, properties, structure, degradation process and factor affecting degradation. Then the next special polymer included in your syllabus, that is electroluminescent polymer, or the example of that polymer included, that is polyphenylene vinylene, means PPV. So before study polyphenylene vinylene, then what is electroluminescent material or what is electroluminescent? The property in which a material produces bright light of different color when stimulated electronically is known as a electroluminescent polymer. That is, we use the beautiful color lighting during the marriage and Diwali or many more purpose. Then this is the most common example of, that is, use of electroluminescent polymer PPV. So the property in which material produce what? Different color bright light. But when after the stimulation of that material electronically, the property is known as electroluminescent, and the material which show the electroluminescence is called as electroluminescent material or known as electroluminescent polymer. So the structure of electroluminescent polymer, it containing phenylene vinylene group. See, that is a phenylene and this is a vinylene group. Such a number of phenylene and vinylene group linked together, that is, it is a polymer, that is polyphenylene vinylene, and it can be prepared by using the precursor polymer, that is it can be prepared from the precursor polymer in a vacuum. So properties. PPV is a diamagnetic material. It has a very low intrinsic electrical conductivity. It gives bright yellow fluorescence. It is insoluble in water. Its conductivity increase on doping. That is, generally it shows the diamagnetism. It is a very low intrinsic electrical conductivity. It is electrical conductance, but it is a very low, and it conductivity increase on what? Doping process. That is, either we use the oxidative doping or reductive doping. It gives bright yellow fluorescence. It is insoluble in water. So applications. Again, it is a widely used polymer in the various